Hello, everybody. I hope you can see my monitor. So one of the homeworks, you had to compare the fiber diameter for different settings. Let's assume for a moment that we have, so let's see here, let's assume that we have fiber diameter of 0.95 micrometers plus minus 0.5 microns. Let's write it like this. Or, and another fiber settings, it has a diameter of 1.1 micrometer plus minus 0.55 microns. Now, let's see, the diameter is something like 0.95 and 1.1. In this case, let's assume that we are going to have an average of, so let's write this one as 0.95. Let's write this one 1.1. And the standard deviation, this error, which is here 0.5 microns, this is going to be 0.5, this is 0.55. So with these settings, we are going to have the following. Let me see for a moment. Yeah, let's see what this corresponds to. So we have lean space. We are producing some data points. Let them be from -4 to +4, because this is the reasonable range, and we want to produce 100 data. So if you evaluate this one, this is what we obtain. So this X, it's a set of numbers which so the range from -4 to +4, we have 100 data points. Then we have to produce, actually, and let's notice here this equation on line 20. This states that y1 is equal to exponential to the power x minus x1, where x1 is the center of the Gaussian distribution, squared divided by 2 sigma s1 squared. Okay, so you have a look at this expression. Let's put here semicolon because we don't want to print this one. And let's look at this whole graph, what we obtain. Evaluate the selection. And we're going to print the figure. So here we go. So what we observe here, we see that the line in blue, it is centered at 0.95. The other one, it is centered at 1.1. And their respective standard deviations, it is the thickness, which is going to be, let me see for a moment. I'm not very good with this new settings of, okay. No, I don't know how to do this. Insert. So this is 0.44. And this is 1.57. So let's have a look at this. No, this is not very correct because, okay, now let's read. No, okay, sorry. So let's try to read these two data points on the, how can I take this away? This is gone, it is easy. So let's read these two x values, which are on the red line. This red line, let's see, 1.73 minus 0.44. So these values that we can see here, let's see what we get. This is 1.73 minus 0.44. We get 1.29. So this 1.29, this answer here, it is in fact this width along these, between these two lines. Okay, so the width of the Gaussian distribution, it should be approximately this much, because the sigma, it is 0.55 times 2, this is 1.1. So this is the meaning of having something averaged out at 1.1, which is this curve in red, and having a sigma plus minus 0.55. Now, question is, we have two different Gaussian distribution, normal distribution that look like as shown here. The question is this: are these any different? Are these fibers any different? The first answer would be no, because there is so much of an overlap. The first perception is the following: since x2 is 1.1 and x1 is 0.95, it looks like x2, which is the second set of fibers, they have a larger diameter. Someone could also say this, because 1.1 minus 0.95, you get 0.15. So it looks like the second set, it is larger in diameter. But when we look at this distribution, it looks like all the values in blue, they are encapsulated, or they are within the distribution of the red curve. Okay, so in this case, it might be difficult for someone to say that. Of course, it looks like it's slightly larger, but you cannot exactly state that the distributions are very much different. But let's now assume another distribution. Let's assume that the average, it's let's call this one, let's call this x3. Let's do this one 1.2. The standard deviation, let's make this one 0.2. And with this new distribution, let's obtain, let's call this one, what was this, x3 we said? Yeah, we call this one, but if we call this one, actually, let's call this one also x2. Let's call this, this is y3. This is y3. We have a new sigma. Let's consider this one figure 11. And with all this data, let's try to see evaluate selection. So here we have another distribution. And in this case, here we have the same question. Are these data any different? Now, again, the curve in red, this is almost encapsulated within the blue. So one could argue that these are not any different. So if we pick any value somewhere here where the mouse is, this has an equal probability of being either in the blue distribution or in the red one. So for a moment, let's have this one, let's make this one 0.8 with a standard deviation of 0.2. And let's see what we see in this new distribution, evaluate selection. So here we have a third distribution, and if you want to get some more details of what this data is about, we see a data which has an average of 0.8, another data with an average of 1.2, with respective standard deviation of 0.2, both of them. Now, here in this case, we observe a more separable two different data sets which are separable. So in this case, we could say that the fibers which corresponds to the blue line are all different from the fibers which correspond to the histogram shown by the red line in here. So this is something that we can compare results where we have the average value and the standard deviation provided for those. Now, in order to experiment a little bit with these codes, you can what we need to know is that in general, the Gaussian distribution of a data set, it can be described by this equation here in line 3, or these two equations in line 20 or 21. Okay, and the x1 and x2, it corresponds to the center of this Gaussian distribution, which in this case is something between 0.8 and 0.9, as we can see the center of these Gaussians. And the sigma, which is denoted here as S1 and S2, this would be the distribution.